Hey, we're at gotomath.com. Click on the algebra. Let's go down to operations with radical expressions, and we're going to be looking at something. We're going to be looking at looks like 4.2. Right. So we have 4 roots of 162 x plus 4 roots of 32 x. Seems like I've already worked this problem for some reason. I don't know. Maybe that was in a different section. Okay. Whatever. Alright, we got to break this 162x up. You know, the goal here is we need to get some like radicals going on here, and these are definitely not like. The radicands are different, but we're going to maneuver on around and see how we can do this. So what I'm going to do here is I'm going to take a small prime number and divide it into 162, and I'm going to try 3. So we're going to have 4 roots of 3 goes into 162 54 times, right? 3 times 54. Let's see, 1, 2, 15. Yeah, okay. And then what do we got going on over here? We got 4 roots of, let's see, 2 to the 5th is 32. So I can actually break 2 to the 5th is 32, right? So we can break this up as 2 to the 4th times 2x. So I got a feeling we're going to need to get a 2x over here as one of our like radicals. And 4 roots of, right, 2 to the 4th is just going to be 2. Alright. So let's go through and still break this thing down. So we got 4 roots of, let's see, 54 can be written as 6 times 9. I see some 3's in there. I see lots of 3's. Hey, let's just go ahead and write this like that. Let's just do that. Okay. So this is 2 times 3. That's 3 times 3. Well, there's 3. Let's see, we got to get a 4 here, don't we? Well, let's just write this out. 3 times 2 times 3, and then, okay, so I see 4 3's going on here. So we're going to have 3 to the 4th times 2x. There's our 2x right there. Good. So we got 4 roots of plus, we'll go ahead and just bring this down. So we have 2 times 4 roots of 2x. Right, and so now we can take the 4th root of 3 to the 4th, and that's going to give us 3 square roots of 2x plus 2 times 4 roots of 2x. We have like radicals now, and we just add their coefficients. We get 5 times square root of 2x. Wait a minute. Ooh, man, I about made a mistake. There's a 4 as an index number in there. Okay, I don't want to forget that. Alright, okay, well, let's see how much time we got over here at gotomath.com. Let's do another one. We got 4 roots of, since we're on a roll, 48 x to the 5th minus 4 roots of 3x to the 5th. I haven't been telling any stories lately, I've noticed. Alright, let's break this 48 up. 6 times 8. We know that 6 times 8 off the top of our heads 48. And if we know that, well, we should write that down. Man, I just don't. Oh, you know what? We can do this. 3 times x to the 4th times x. Okay. Now, what do we got going on here? We got 2 times 3. 4 is 2 cubed, isn't it? Okay. Probably shouldn't have wrote that like that, but minus 4, right? 3x to the 4th times x. So as you can see here, we got 2 cubed and a 2, so I can write this as 2 to the 4th times 3 times, whoa. I'm just now seeing that for some reason. I feel like I'm asleep or something. Minus, alright, we'll finish up on this next one, promise. Yeah, I can't believe I didn't start breaking that down like I did this one over here. I just didn't see it. So we got 4 roots of 2 to the 4th, so that's going to make that a 2 out front. Same thing with this x to the 4th right here. We'll be able to bring x, and then we got 4 roots of, and the only thing that's going to be left under here is 3x minus, and let's see, this x here, we can bring that out front. So we got 3x. Now we got like radicals, and also what's important, we got some like terms out here in the front. 2x minus x is just going to leave us with an x times 4 roots of 3x. Okay, and we're done. So we're over here at gotomath.com. This is where you should be. All right, and I'll see you in the next problem.